Hello EDP students, I am m.felicetti and in this video I am going to take you through some of the fundamentals of electronics. So the first thing we're going to look at is a two-terminal component. So this is some unknown component in an electronic circuit and it has two terminals, okay? Meaning it can be connected to other components only via these two terminals. So we could have a component here connected here, we might have two components here connected here, but it's only through these two terminals. Now the first fundamental thing we'll look at is voltage. So this is the electric potential between 2 points. So what does this mean? Well, let's say our component is a battery. So a battery is a component that provides the force to move electrons. Okay? And electrons are negatively charged, just to note. So this force to move electrons between 2 points is the voltage. So what I'm going to do with my battery here is I'm going to label one of the terminals with a plus and one with a minus. So the one with the plus is our positive terminal, and this has a higher potential. And it can be seen as more attractive to electrons as unlike charges attract. Whereas the negative terminal has a lower potential and a negative charge, hence will repel the electrons. Okay? So if we want to connect our battery to another component, like so, we now create a closed circuit and a path for electrons to move. Okay? So you can see that the electrons are moving from the negative to positive. You can think of this as the electrons being pushed from one end and pulled from the other. Okay, our negative is pushing them away and our positive term is pulling them in. Okay? Now the electrons are moving at a particular rate from this terminal to this terminal. So if we take a point in our circuit, let's say here, and measured the change in charge over the change in time at this point, we get what's known as current. So current is a measure of the flow of electrons. Now, particular materials and components will slow the flow of electrons, reducing the current. And this is known as resistance. So, for example, let's say our component here is just copper. This has a low resistance and will not impede the flow of electrons very much, compared to, say, wood, which has a high resistance. Hence, it would slow the flow dramatically. So, often we want to set the current to a particular value. To do this, we use a component known as a resistor, which you'll see very soon in the labs. And these components have a known resistance. And so let's have a look at how voltage, current, and resistance relates. So voltage, current, and resistance relate through what is known as Ohm's law. And this states V equals I times R. So V is voltage, measured in volts, I is current, measured in amps, and R is resistance, measured in ohms. So now let's have a look at a circuit. So we have this circuit here, and we have a 9-volt battery, we have a 100 ohm resistor, and we want to find the current. So with this, we saw that our electron flow was going in this direction, but the current is going in the opposite direction of the electron flow, and this is known as conventional current. Now, we want to find I, so we use Ohm's law, rearrange it a little bit, and we get V over R. We then plug in the values, get 9 over 100, which gives us 0.09 of an amp, or 90 milliamps. That should be quite easy. Alright, thank you very much.